anyway, today we're going to talk about sets of numbers. This should be reviewed. You've looked at this over and over and over again. This is something you learned like way back in middle school, if not before that. But the sets of numbers, this is a diagram that you have in your book. That's all fine and good. You can look at that if you choose to. What I'm going to do is I'm going to go through these terms at the bottom just so that we can kind of understand those. Remember, the natural numbers are the very first numbers you learned when you were a kid. They were the ones that you count on your finger. 1, 2, 3, 4, 5, and all of that good stuff. We symbolize the naturals with the letter N. Then came the whole numbers. You learned that there was such thing as 0. We symbolize the whole numbers as a W. And then came the integers. The integers, you found out that there was something known as a negative. We symbolize those with Z. Okay. Now, the thing about integers, every negative number is not an integer. Okay? And that's important to keep in mind because then we have the rationals. The rationals are fractions terminating or repeating decimals. So I had somebody ask me the question, this would be an integer, right? And I said, what do you think I said?
Yes.
Why is that not an integer? It's a decimal, that's right. The integers are just the positive or negative natural numbers plus 0. Okay, or the positive or negative whole numbers. So make sure you understand, just because you see a negative sign does not always mean it's going to be an integer. The integer has to have no decimal part, no fraction part. The rationals are fractions terminating and repeating decimals, and then the irrationals are non-terminating, non-repeating decimals. Most famous irrational number we know is pi. Rationals we symbolize with Q, irrationals we symbolize with I. And you're probably wondering, well, why do you symbolize Q for the rationals? That's because every number, okay, is considered to be a real number. And so when we refer to all numbers, those are the real numbers. And so the real numbers takes R as its symbol. And so that's why the rationals, we pick the next one, which is Q. Okay? So irrationals, basically when we think about irrationals, we think about square roots that we can't take the square root of, like root 3, root 7, root 5. Now say for example I gave you root 9. Can you take the square root of that? Yeah, what is the square root of 9? 3. So if you can take the square root of it, don't automatically assume it's an irrational just because you see a square root. Okay, so 3 would be a natural, a whole, an integer, a rational, and a real. And we're going to look at some examples of those right now. So, name the sets of numbers to which each number belongs. So negative 23. Is negative 23 a natural?
No.
No. Whole.
No.
Integer.
Yes.
So it is an integer. If it's an integer, that means it is a rational. And we know every number is classified as a real. So you could write it that way, or you could write it Z, Q, R. You could use the symbols. I don't care. So if you want to use the symbols, that's great. Root 50. Can you take the square root of 50? To get a single number? No. So then what do we know it's classified as? An irrational. And every number we know is a real. So the question is, am I always going to answer real? Yeah. Real should be your answer on every one. So you should be able to get one right. Irrational are symbolized with I. Real is symbolized with R. Negative 4/9. Negative 4/9 is what did you say, Justin? Rational. What else is it classified as? Real. So you could use your symbol Q and R. So that's what I expect on those problems. All you have to do is classify numbers. Shouldn't be too difficult. The next one, we're going to review these real number properties. This is again in your book as well. It's at the top of the page. And we're going to review the commutative property of addition. Now when I think of commutative, I think of commute. Every day we commute to school. So when I think about commute, I think about school, or home to school, and then school to home, because that's what you do every day. So here is your home. Home to school is what you do every day. And then once we're done with school, we go school to home. So commutative means commute. Home to school, school to home. Now notice if there's a commutative of addition, a commutative of multiplication. That means 2. Associative, I think about about the big breakup. Okay, the big breakup. Because when you think about it, you got a couple. Got a couple here, A and B. And then we have C over here. C's just a single. Then the big breakup occurs. What happens? B goes with C and A is left out. So think about associate, the big breakup. They changed associations. Okay, they associated with somebody else. Notice that works with multiplication as well. You got a couple, one left out. There's the breakup. So now A is left out and B and C are together. Identity basically means if you add 0 to any number, you get the number itself. You multiply any number by 1, you get the number itself. Notice it works for addition and multiplication. Inverse. What is negative A always, in other words, referred to as? What's another name for negative A in relation to A? It's inverse, or it's opposite. Good. Okay, so basically a number and its opposite is 0. That's what the inverse states. For multiplication, it's a number and its, what's that? Reciprocal. Good. Is 1. Closure just states if you add any two numbers, you get a number. So if you add 5 and 10, you're guaranteed it's going to be a number. Same thing when you multiply. And then the distributive property, probably the most famous one that's the easiest to identify. We distribute the A to both, and that's how you get the distributive property. So now what we're going to do is I'm going to give you a little bit of a problem here. Here you go. Vote now. I want you to look at that. Name the property that's illustrated.
Okay, I got it. Wait, my thing.
Name the
is-
property that's illustrated.
I'm pretty sure that's good.
A,
for
B,
it.
C, or D.
I think I'll go with that one.
A, B, C, or D.
Now, is this like my expression forever now?
No,
Because it has my name on it.
every day. Okay, A, B, C, or D. Oh, the answer is B. This is the big breakup one.
Oh.
Okay, this is the big breakup one. We got a couple, one left out. Now we've got the other person left out and a new couple. Okay, let's look at this one. Let me go ahead and get that out of your way. Name of the property illustrated.
Holy crap.
It's bound to be right somewhere.
We got this.
Just keep guessing the same.
Okay, so let's go ahead and look at this one and see what comes up.
Voting, a vote.
Alrighty, and the answer is C. Very good. Distributive. Reason why distributive works is because notice I've taken 2 times 6 to get 12 and 2 times 9 to get 18. So that is the distributive property. Okay, find the additive inverse and the multiplicative inverse. So these should be fairly easy. Additive inverse. What do you think that's going to be in this problem? Yep, negative what?
1.25.
Negative 1.25. Very good. Basically, the additive inverse, you're just going to take the opposite of whatever it is. Multiplicative inverse means what times 1.25 gives me 1. Okay? So another way to think about the multiplicative inverse, what was another word for it?
Oh my god.
What was another word for it? Reciprocal. So when we take the reciprocal, that means we take 1 over the number, right? So what is 1 divided by 1.25?
You're supposed to do
1 divided by 1.25 comes out to be a fairly easy decimal. 0.8. So that's one way. The other way is, let's write this as a fraction. That's 1 1/4, correct? But how could I write that as an improper? 5/4. So then the multiplicative inverse would be the reciprocal of that, which is 4/5. So I will take either 0.8 or 4/5. Okay, we've got a couple more of these. We're going to move fairly quick through them because they don't take that long. Find the additive inverse and the multiplicative inverse. What's the additive inverse here? 5/8. What's the multiplicative inverse?
negative 8/5.
Negative 8/5. Right, so the additive inverse, you switch the signs.
Shut up. Okay.
The multiplicative inverse, you flip it. Let's look at the next one. Find the additive inverse. So, additive inverse of root 7,
Square root or square.
negative root 7. All you do is change the
Oh,
signs. Good.
okay, got it.
Multiplicative inverse.
Now it's 7 squared.
No, multiplicative inverse, think back to
1/7.
the very first thing. 1 over root 7.
What?
But one of my rules is you can't have a square in the denominator. So what we need to do is get rid of this. To get rid of the square root, all you do is multiply by root 7 over root 7. 1 times root 7 is root 7. In the bottom, root 7 times root 7 is root 49. What is the square root of 49? 7. So that is your multiplicative inverse. A lot of sevens, you're right. Okay, let's look, oops, skipped one. Let's look at this one. Find the additive inverse and the multiplicative inverse. What's the additive inverse going to be?
-2.
-2.5, very good. Multiplicative inverse.
Okay, we got this, guys.
What is this as an improper?
Wait,
5 over 2.
5 over 2. 5 over 2.
So what's the multiplicative inverse?
5 over 2.
2/5.
What? Sorry.
All right, let's look at this next one. The prices of the components of a computer package offered by Computer Depot are shown in the table. If a 6% sales tax is added to the purchase price, how much sales tax is charged for this computer package? And so, if you think about this, and this is kind of one of the examples your book went through, it took 6% of the computer, 6% of the monitor, 6% of the printer, 6% of the digital camera, and 6% of the software bundle, and it added all those up. Okay, I think that's a little bit of a pain. So what I'm going to do is I'm going to do what the stores do. The stores add up your total bill, right? And then what they do is they assess sales tax based on your total bill. So go ahead and add those up for me. Tell me what you get for $. So you have your computer at $359.95, your monitor at $219.99, your printer at $79, your digital camera at $149.50, and your software bundle at $99. $907.44. Did somebody else get that?
Yep.
So then now, I'm going to take that times 6%, which I know 6% is 0.06. What do you get?
54.45.
54.45. I think it comes out to be 54.446,
Yeah.
something. Okay, so as a result, that would round up, and this would be your sales tax. Now, just a little tidbit, sales tax applies to everything. So if you go out and buy a new car, you're going to have to pay sales tax on that. And that's something a lot of people don't understand or realize. If you go out and buy a $20,000 car, figure out what the sales tax would be. The sales tax in our area is 7%. So figure out how much sales tax you're going to pay. $1,400. Now that's not counting your license fees and your property tax, which you can probably add another $400 to $500 on that. So in the first month of you owning your brand new car, you're going to have to go to the courthouse and you're going to have to write a check for roughly $2,000. That's not counting any payment on the vehicle. That's your taxes alone. So just keep that in mind. If you buy a new car, you're going to have to pay taxes on it. Simplify. This is distributive. This one should be fairly easy. What I'm going to do here is I'm going to distribute the 3 to the 4m and the 2n. And when I do that, I get 12m minus 6n. Now when I distribute this here, I need to make sure I distribute the -2. So I get -6m, oops, somehow that, -6m minus 2n. Now what I need to do is add like terms. How many m's do I have? Yep, and so when I add them together, what do I get? 6m minus 8n, and that is your solution. Questions? Fairly quick lesson today. Your assignment for tomorrow is 18 through 42. Now that sounds like a lot, but if you look at them, a lot of them are just name the property, find the additive inverse, find the multiplicative inverse. So they should be fairly quick. That is due tomorrow.